diagnostic benchmark. What's in an element? I can identify that protons identify elements and valence electrons determine reactivity. So just in your I can statement, we can look that protons identify elements. And here inside the nucleus, we have 8 protons. We can identify this atom by going to the periodic table and looking at the atomic number 8. The atomic number equals protons, which equal electrons. So we can identify this atom as oxygen. Starter. An atom is mostly empty space with a dense positive nucleus. Name the 3 subatomic particles that make up this atom and each particle's electrical charge, location, and mass. So looking at oxygen, the atom of oxygen, we can say that an atom consists of 3 subatomic particles. Protons, which are in the nucleus, neutrons are also in the nucleus, and electrons, which are found outside the nucleus. Protons have a positive charge, neutrons would have neutral charge, and electrons would have a negative charge. The masses. Protons and neutrons' mass are the same. It's 1 atomic mass unit, and they're found inside the nucleus. All the mass of an atom is found inside the nucleus. Your electrons' mass are so small, their mass is negligible. Parts of an atom matching activity. We're going to drag and drop the descriptor cards to the correct place on an atom. So here inside the center of an atom, we understand that's the nucleus. So we can drag and drop that. That's what the bracket is pointing to here. Then inside the nucleus, these green subatomic particles are protons. I know that because they have a positive electrical charge. The blue subatomic particles are neutrons, and I know that because they have a neutral charge or no charge, so I don't see a positive or a negative sign. Here, this would be pointing to your electrons, and I know those are my electrons because those are found outside the nucleus. They orbit the nucleus. And this electron here is special because it is the electron found in the outermost shell, and that's a valence electron. Valence electrons determine chemical reactivity of an atom. So based on how many electrons there are in that outer shell, we can discuss the atom's reactivity. And then this whole area that the bracket is pointing to is the electron cloud. Structure of an atom. Let's read about the nucleus. The nucleus is the center of the atom. The nucleus contains positive protons and neutral neutrons. Since each proton and neutron in the nucleus has a mass of 1 atomic mass unit, AMU, we can add the number of protons and neutrons together to find the atomic mass. How many protons are in the element lithium? So this is a lithium atom here, and if we want to know how many protons, we can count 1, 2, 3. Or we can go to the periodic table and look at the atomic number. The atomic number equals your protons and equals your electrons. Lithium has 4 neutrons. What is its atomic mass? So the atomic mass is the decimal below the symbol, and we would round that. So looking at the digit after the decimal, if that's greater than 5, we would round this to a whole number 7. So we would then call that the mass number. When we have the mass number, we can subtract the atomic number, the number of protons, to find the neutrons. So 7 subtract 3 would give us 4 neutrons. The periodic table shows the mass of each element as a decimal. When we use the atomic mass to find the number of protons and neutrons, we would round that mass number. Structure of an atom. Let's read about charges on particles. Protons carry a positive electrical charge. So our protons are always positive. You can remember that. P for proton, P for positive. Electrons carry a negative electrical charge, and those electrons are found outside the nucleus, orbiting the nucleus. Neutrons have no charge, so neutrons, they would have no electrical charge, no positive or negative. The most stable form of an atom is electrically neutral. This means that the number of protons equals the number of electrons. So in order to have a neutral atom, like the overall charge of this atom would be neutral. It's not going to have any charge because your protons, 8, will equal your number of electrons, 8. So always neutral atoms, protons, equal the number of electrons. They cancel each other out. So if you have 8 positives and then you have 8 negatives, if you subtract, they cancel each other out. The overall charge is 0. So we say it's neutral. For example, look at the element oxygen. Oxygen's atomic number is 8, which means it has 8 positive protons. Therefore, in a stable oxygen atom, there are 8 electrons. The positive and negative charges are balanced. Okay, so again, to have a neutral atom, your number of protons will equal your number of electrons. Let's take some notes on the makeup of an element. The atomic number indicates the number of protons and identifies the element. So I can identify this element as oxygen by looking at the number of protons in the nucleus. The atomic mass, 15.9, rounded indicates the number of protons and neutrons. So this is a combination of your protons and neutrons in the nucleus. Remember, your mass is found in the nucleus. We use the ape-man strategy to find the number of neutrons. So ape stands for atomic number equals protons equals electrons. Man would be your mass number. So 15.9 rounds to 16. We take that mass number and subtract our atomic number, 8, to get our number of neutrons. So 16 subtract 8 is 8. So fluorine has an atomic number of 9 and a mass number of 19. How many neutrons are in this atom? So we would take that mass number 19 and subtract the atomic number 9 to get our number of neutrons. So we would have 10 neutrons. All right, let's take some notes on chemical reactivity. The number of valence electrons, group number, will determine how reactive an element is. So let's go to the periodic table and have a look. So group numbers are above the vertical column. So this is group number 1. That number 1 is indicating that all these elements vertically up and down have 1 valence electron. Group 2. All of these elements would have 2 valence electrons. Now we skip these group numbers here and we go to group 13 and you look at the second digit only. So all these elements would have 3 valence electrons. All these elements in group 14 would have 4. In group 15 they would have 5, 6, 7, and 8. Okay, so again, the number of valence electrons is the group number above that vertical column. It will determine how reactive an element will be. If an element has valence electrons to gain or lose, it will be very reactive. Group 1 and group 17 are the most reactive elements. In group 1, we call them the givers, and in group 17, we call them the takers. So let's have a look at that periodic table again. So first of all elements want to have a full outer shell with valence electrons. So for example, group 18, they all have 8 valence electrons in their outer shell. That's what all the other groups want to have, 8, but they don't. So they're going to react to try to get 8. So in group 1, these guys only have 1 valence electron in their outer shell. We call these guys the givers because it's easier for them to give that 1 valence electron than to take on 7 to get a total of 8 valence electrons. So these guys are the givers. They're extremely reactive. They'll do anything it takes to get rid of that 1 valence electron. Then if we come over here to group 17, all these elements have 7 valence electrons and they just need 1 more to fill their shell like group 18. So these guys are the takers. They're going to do whatever it takes to just get 1 more valence electron to complete that outer electron shell. And then, of course, group 2, group 13, 14, 15, and 16 are also reactive, but not extremely reactive like group 1 and group 17. If an element has all 8 valence electrons, it's considered to be a stable atom, and it's a non-reactive atom. And those are your noble gases. So going back over to the periodic table, in group 18, all these elements have 8 valence electrons in that outer shell, so they're stable. They're not going to react because they have exactly what they need. And all of these elements are called the noble gases. They're the least reactive out of all the elements on the periodic table. All right, so let's have some practice with reactivity. So, which element would have chemical properties similar to oxygen? So when we talk about chemical properties, we have to look at those valence electrons, those electrons in the outer shell. So since we're given the atom of oxygen here, we can count how many valence electrons there are. So 2, 4, 5, 6. So oxygen has 6 valence electrons. It needs 2 more to fill that outer shell, 1 here and 1 here. So if we want to find an atom who has similar chemical properties to oxygen, we'd have to go to the periodic table and understand what group number oxygen is in. So oxygen is in group 16 with 6 valence electrons. Remember, it only needed 2 more. So what other elements have similar chemical properties? Those are going to be the elements that are in the same group as oxygen because they're all going to behave similarly. They all need 2 valence electrons to fill that shell. So going back to our question, is it going to be neon, fluorine, nitrogen, or sulfur? So if we look, we can see sulfur is in the same group as oxygen, so our answer choice would have been sulfur. Fluorine is in group 17, so we would not choose fluorine. Okay? All right, so that would have been your answer here. And neon is a noble gas in group 18, so we would not have chosen that. All right, let's have another practice. It reads, which element would have chemical properties similar to magnesium? So again, if I have similar chemical properties as magnesium, I'm going to be in the same group as magnesium. And here I can understand that magnesium is in group 2 because it has 2 valence electrons. So I'm going to go to my periodic table and find magnesium, and sure enough, it's in group 2 with 2 valence electrons. So any of these elements that are in the same group are going to have similar chemical properties as magnesium. Since they only have 2 valence electrons, they need 6 more to get 8 in their outer shell. So going back here, potassium, let's see if potassium is in the same group. No, potassium is in group 1. I can see calcium, beryllium, and strontium are in the same group. So Be, beryllium, would be in the same group as magnesium with 2 valence electrons. Okay, let's have a little review on the periodic table. What colored portion is being represented? So if you look here, that's a row, here's a row. So all these are color-coded. So what's being represented here? Your periods are being represented by these colors. So this is period 1 going across, period 2, period 3 is orange, period 4 is yellow, period 5 light blue, period 6, and period 7. Remember, periods, these are horizontal rows on the periodic table. I remember that because, again, I write a sentence and I place a period. So my periods always go horizontally. They have the same number of atomic orbitals or shells or energy shells. Those are the rings around the nucleus where you can find your electrons. What color portion is being represented here? So we're looking vertically up and down now. So this is group 1, group 2, group 13, group 14. So these are called groups. They are vertical columns on the periodic table. Elements in these tend to have the same chemical properties. They have the same number of valence electrons in their outer orbital or shell. So if we look at group 18, all of these noble gases have 8 valence electrons in their outer shell. They're unreactive. Okay, and remember your most reactive groups are group 1 and group 17. What colored portion is being represented? So here on the periodic table, all these green elements are going to be metals. They tend to be shiny, good conductors of heat and electricity. These elements are ductile, which means they can be drawn into thin wires, and they're malleable. They could be hammered into sheets. They're solid at room temperature, with the exception of mercury, which is right here. Mercury is a liquid at room temperature. What colored portion is being represented here? So along this black zigzag line or staircase, we have our metalloids. They have properties of both metals and nonmetals, and they partially conduct electricity. So they're so-so conductors, and they are important in the production of semiconductors for computers. So what colored portion is being represented here with the also including hydrogen? These are going to be our nonmetals. They're poor conductors of heat and electricity. They're brittle, not malleable. They're not able to be hammered into thin sheets or wires. Some are liquids as well as gases. Which element has similar properties to sodium but has a greater atomic mass? Now remember, when they're asking you about similar properties, you want to look at groups. Groups go vertically up and down. So if they're asking us what element has similar properties, that means similar chemical properties as sodium. So you want to look vertically and see what elements are in the same group as sodium because they have similar chemical properties because of their valence electron. So I'm going to go to the periodic table so we can find sodium. And if you see here, sodium is right here. It's in group 1. So all these elements vertically have similar chemical properties as sodium. Okay, and you can see that potassium is in the same group. They all behave similarly. They have 1 valence electron. They want to get rid of it. So their next inner shell is full because it's very difficult to take on 7 more valence electrons. So our answer would be potassium. Potassium's in the same group as sodium, so they have similar chemical properties. Today, for your assignment, you're going to use the ape-man strategy to complete what's in an element. You're going to calculate the number of protons, neutrons, and electrons of an atom.